Welcome to this HP Expert One presentation. This video is the second part discussing IP subnetting. In the first video, I showed you two methods to work out subnet, first host, last host, and broadcast address when presented with an IP address and subnet mask. In this video, we're going to continue the discussion looking at how to subnet a network based on requirements for a certain number of subnets or a certain number of hosts per subnet. So firstly, some reasons why you would do subnetting, and then I'm going to show you how to do subnetting. The reason may be that your remote site only has a few devices. So in this example, let's say you've got 3 PCs on segment 1 and 2 PCs on segment 2. It's unlikely that the head office is going to allocate you separate subnets that can support 254 hosts for this scenario. A /24 subnet supports 254 hosts. Why do you need a separate subnet for each of these segments? It makes more sense to take one subnet and subdivide it to support a topology like this. So that's a very simple example of where you may be required to do subnetting. Another reason to subnet is that the original classful networks, such as Class A, support a large number of hosts. So if you were allocated a network of 10.0.0.0/8, you would end up having 16 million odd hosts on a single segment. The network is going to grind to a halt because of broadcasts. That number of hosts on a single segment is not practically possible. The number of broadcasts and the amount of traffic on the network is going to result in your network falling apart. A lot of network engineers, based on best practices, will as a maximum put 254 hosts on a subnet. That's the number of hosts that a Class C subnet supports. So if you were allocated a Class A network, you'd probably want to subnet that down to 254 hosts. A Class B subnet supports about 16,000 hosts per subnet. And once again, that's far too many hosts on a single subnet or network for that segment to operate properly. So you're going to want to subdivide that once again into multiple subnets. On a point-to-point link, only 2 host addresses are required. So it makes sense once again to subnet that down even further or subdivide a subnet to a point where it only supports 2 hosts per subnet. So there are many reasons to do subnetting in IP version 4. The formula to remember to work out the number of hosts supported on a subnet is 2 to the power of n minus 2, where n is the number of binary bits in the host portion. So as an example, if we take a Class A network, which is 32 bits in size, but 24 bits are host and 8 bits are network. So 2 to the power of 24, in other words, the host portion, equals 16 million, minus 2 for the network and the broadcast address equals this value. That's the number of hosts supported on a Class A network. But in reality, once again, that would never work. So it's important that you understand subnetting, and I'm hoping that this video will help you for both the real world and for study purposes. Now that we've explained the why for subnetting, let's look at the how. I believe the best way to do subnetting is to use the binary method with some extra shortcuts that I'm going to show you in the following slides. There are many ways, once again, to do subnetting. Use the method that you're most comfortable with. But I think the binary method will ensure that you can subnet any scenario that you come across, and the extra shortcuts will make it quicker and easier to do the subnetting. Now it's important to remember that subnetting involves stealing or taking away bits from the host portion of an address. So think of stealing for subnetting. S for stealing, S for subnetting. You then allocate those stolen bits to the network portion of the new address. So you're taking away bits from the host portion of the address, allocating those bits to the network portion, which allows us to create multiple new subnets out of a single subnet. Here are two important rules to remember. When asked for the number of hosts, use the formula 2 to the n minus 2. I've already demonstrated this formula in the previous example when I worked out the number of hosts available on a Class A network. But remember, please, to work out the number of hosts, use the formula 2 to the n minus 2. And also note that you count host bits from right to left. When asked for the number of networks, use the formula 2 to the n. Notice there is no minus 2. And also remember to count the bits from left to right. This can often get confusing. Please remember, formula for hosts is 2 to the n minus 2. Formula for networks is 2 to the n. The reason why we deduct 2 in the host formula is we need to allocate an address for the broadcast address and an address for the subnet address. Hence, you lose 2 addresses. The remaining addresses can be applied for hosts in that subnet. When working out the number of networks, you do not subtract 2 from the formula. Also, don't forget, hosts right to left, networks left to right. Subnetting calculators can obviously make your life a lot easier, but if you need to work out subnets manually, this shortcut table can save you a lot of time and effort. This is simple binary. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and then you can just continue to, let's say, 2 to the power of 10. You could add other values if you like, but this is a shortcut table that will initially get you started if you need to answer subnetting questions. So let's do an example. The question we've been given is that ABC Limited has been allocated subnet 10.110/24 for a small office in London. Paul, the network administrator, needs to split this subnet into smaller subnets. In this example, each subnet needs to support 14 devices. He's asked for your help, as he's not sure about subnetting. The first thing we need to decide is which formula are we going to use. Are we working out hosts or networks? In this example, we've been asked to work out the number of hosts, so we use the formula 2 to the n minus 2. Once again, we've been asked for hosts, so we're going to count the bits from right to left. So 2 things to be aware of when answering questions is which formula are we going to use and which way are we going to count the bits. 2 to the n minus 2, count from right to left. The second step is to work out how many bits are required to cover the number of hosts, which is what we've been asked for in this example, or networks in other examples. So in our example, we've been asked for 14 hosts. How many bits would we require? So going back to our table, we can see that 2 to the power of 4 is 16. Use the shortcut table just to help you quickly work out values. So with hosts, we're using the formula 2 to the n minus 2. Therefore, 2 to the power of 4 minus 2 gives us 16 minus 2, and therefore results in an answer of 14. 4 binary bits support 14 hosts per subnet. We now know that we need to steal 4 bits from the host portion and allocate that to the network portion to support 14 hosts. In step 3, we're going to convert the host portion of the original network into binary. The network we were allocated was 10.110/24, which could also be written as 10.110.255.255.255.0. The network portion of this address is 10.111 and the host portion is 0. For speed and efficiency, we're not going to convert the network portion into binary. We're only going to convert the host portion into binary. So 8 binary zeros is the same as decimal 0. We have taken our host portion and converted it to binary. So from the host portion, which is 8 bits in size, only 4 bits are now required to support 14 hosts. Counting from the right-hand side, because we've been asked for hosts, we allocate 4 bits to hosts, and the remaining bits of the original host portion, which is 4 bits in this example, is allocated to subnet. So originally we had 8 bits for host. Counting from the right-hand side, we allocate 4 bits to host, and the remaining 4 bits can be allocated to the subnet. We have stolen, if you like, 4 bits from the host portion and allocated it to the subnet portion. We were originally given a network of 10.1.1.0. We cannot manipulate the network portion, but we can manipulate or adjust the host portion. So the network portion is left as is. The host portion is adjusted to now support 4 bits for host and 4 bits for subnet. The next step is to work out the new subnet mask. To work out the new subnet mask, you count the number of bits that are part of the network or the subnet, but don't count the host portion. So ignore the host, but add the network and subnet bits together. So from the left-hand side, we're going to count the number of bits in the network and host portion. Now remember that an octet is 8 bits in size, or 8 bits in length. The first octet is 8 bits. In other words, the octet containing 10 is 8 bits in length. The second octet is 8 bits in length. The third octet is 8 bits in length. We have allocated 4 bits to the subnet portion. So 8 plus 8 plus 8 plus 4 equals 28 bits. Or working backwards if you prefer, an IP address is 32 bits in size. There are 4 bits for host, so 32 minus 4 gives you 28 bits. The new network portion of the address is /28. There are 28 bits for network and subnet and 4 bits for host. The last step is to work out the new subnets. The network portion of the address is 10.1.1.1. The subnet portion is 4 bits in length and the host portion is 4 bits in length. I've drawn a line to differentiate between network and subnet and host. So the lines are just there to make it easier to differentiate the various parts of the address. So the first network is equal to 10.1.1.0. Notice this octet is populated with zeros. So the last octet is decimal 0. /28 as worked out in the previous step. 8 bits, 8 bits, 8 bits is 24. Plus 4 bits is 28, which can be written as 10.1.1.0, 255, 255, 255, 240 in dotted decimal notation. So that was the first subnet. To work out the other subnets, go through the various binary combinations for the subnet portion of the address. Please refer to the binary video if you're not sure how to work out the binary. Notice in the first subnet, it's filled with binary zeros. For the second subnet, the subnet portion is filled with 3 binary zeros followed by a binary 1. Converting that to decimal, we've got network 10.1.1, network portion. The fourth octet, you must remember that this is a single octet. So this is 001 followed by 4 zeros. The lines and spaces are only for readability. This is actually 1 octet. So if we convert that back to decimal, it'll be 16. So the network is 10.1.1.16/28, which can also be written as follows. Please note this is not an IP address, this is a network address. 10.1.1.16/28. The third subnet is 0010, just going through the binary combinations. So this is equal to 10.1.1, the network portion. This once again is a single octet. So 0010, 4 binary zeros, which equates to 32 in decimal. So the subnet is 10.1.1.32/28, which can also be written as follows. Now I wouldn't bother doing more than the first 3 or so, because you'll notice a sequence. Here it goes from 0 to 16 to 32. In other words, it's going in multiples of 16. So 32 plus 16 gives you 48. 48 plus 16 gives you 64. And you could continue to work out the other subnets. So I would typically do the first 3 or 4 and then the last one. To work out the last one, you fill the subnet portion with binary 1s. So this is 10.1.1 followed by, and looking at that octet, that equals 240. So the last subnet is 10.1.1 240/28, which can also be written as follows. So how many subnets have we created? Notice we've got 4 bits using the formula 2 to the n, where n equals 4, which is the number of bits. So 2 to the power of 4 gives us 16 subnets. How many hosts per subnet? There are 4 bits in the host portion. The formula is 2 to the n minus 2, which will give us 2 to the power of 4 minus 2, which is 14. We have 14 hosts per subnet, and we have created 16 subnets. Originally, we only had one subnet. We were given subnet 10.110/24. One subnet supporting 254 hosts. This is 8 bits in size. 2 to the power of 8 minus 2 gives you 254 hosts. So we supported originally 254 hosts on one subnet, but now we can support 14 hosts on 16 subnets. We have successfully taken one subnet and subdivided it into multiple subnets, in this case 16, each supporting 14 hosts. Here's another example. Paul from ABC Limited has been allocated a subnet of 10.128.192.0/18 for several offices in the USA. Paul, the network administrator, once again needs to split the subnet into smaller subnets. He requires 30 subnets with as many hosts as possible and has once again asked for your help. The first decision is, which formula are we going to use? In this case, we've been asked for a certain number of networks, not hosts, so we use the formula 2 to the n, and don't forget to count the bits from left to right rather than from right to left. The formula 2 to the n minus 2 is for hosts. Here we have been asked for a certain number of networks or subnets, so we are using the formula 2 to the n. In step 2, we need to work out how many bits are required to cover the number of hosts or networks being asked for. In this example, we were asked for 30 subnets. So how many bits will give us 30 subnets? Well, 2 to the power of 5 will give us 32. So we'll end up having 32 subnets rather than 30 subnets. In other words, we'll have 2 spare. We now know that we need to steal 5 bits from the host portion and allocate that to the network portion. 5 bits gives us 32 networks. We require 30. The third step is to convert the host portion of the original network into binary. So the original network we were given is 10.128.192.0/18, which can also be written as follows in dotted decimal notation. 255 tells us that the first octet is network. 255, second part is network. The 192 implies that the network host portion changes in the third octet. So network, first 2 octets, network host in the third octet, host portion in the fourth octet. So there's a split here between network and host. So we're going to convert both the third and fourth octet to binary. First 2 octets are left in decimal. The third octet is written in binary, which is 11 followed by 6 binary zeros. That equals 192. And the fourth octet is 8 binary zeros, which gives you decimal 0. The original network was 10.128.192.0/18. We are taking 5 bits from the host portion and allocating that to the subnet portion. So the first line was drawn at this point. Now we can draw a second line here to indicate network, subnet, host portions. We have stolen 5 bits from the host portion and allocated that to subnet. How many bits are now used for the network subnet portion? First octet is 8 bits in size, second octet is 8 bits, third octet we have 2 bits for the original network plus 5 bits for the subnet portion. So the total number of bits is 8 bits plus 8 bits plus 2 bits plus 5 bits, which is 23 bits. So the network portion is now /23. Or if you're working backwards, 32-bit IP address minus 9 bits, 8 bits in the last octet, plus 1 bit in the third octet is 9, gives us 23 bits. So it's now possible to work out the new subnets. Once again, to work out the subnets, you go through the various binary combinations for the subnet portion of the address. So the first subnet is 10.128, so 10.128, 2 bits in the third octet are set to 11. As per the subnet we were originally allocated, the subnet portion is filled with zeros, the host portion is filled with zeros. So the third octet equals 192, and the last octet is 0. So the answer is 10.128.192.0/23, which can also be written as follows. For the second octet, it's 10.128.11, and now we're going through the various binary combinations. So it's 10.128. The third octet is 11, 4 binary zeros, followed by binary 1, followed by binary 0. So that is 2 in decimal, 128, 64. So 128 plus 64 plus 2 is 194. Last octet is all zeros, so the last octet is 0/23. Can also be written as follows. So that's the second network. The third network is 10.128. The third octet now has the binary bit changed, so that is 11, 3 binary zeros, 1 0, 0. So network, subnet portion, host portion. But this is a single octet, so you've got to convert it back to decimal as a single octet. So that is 196. So 10.128, 196. Last octet is filled with zeros, so 0/23, which can also be written as 10.128.196.0.255.255.255.40. So let's work out one more. 10.128.11. Notice we're just going through the various binary combinations in the subnet portion. So this, as an octet, looks like this, which equals 198. Last octet is filled with zeros. So the answer is 10.128.198.0/23, or in dotted decimal notation is 10.128.198.0.255.255.255.40. At this point, you can hopefully see a sequence. 192, 194, 196, 198. It's going in multiples of 2. So the next one would be 200, 202, 204, etc., all the way up to the last one. To work out the last subnet, you fill the subnet portion with binary 1s. So 10.128, 11, 5 binary 1s, 0 equals 254. Last octet is filled with zeros, so that'll be a 0/23. So the last one could also be written as follows. So just to reiterate, to work out the subnets, you leave the network portion as it is. The subnet portion goes through the various binary combinations, from being populated with zeros all the way up to being populated with binary 1s. The host portion is always filled with binary zeros. Then you do a conversion. So you need to convert, and don't forget, an octet could contain network, subnet, and host portions. So this octet is a single octet and is therefore 254. Host portion is always zeros. I'm hoping that this helps you learn how to subnet when given a requirement for a certain number of hosts or certain number of subnets. That concludes the second subnetting video. In the 2 subnetting videos, I covered a lot of ground. I showed you how to work out first host, last host, subnet, and broadcast address when presented with an IP address. In the second video, I showed you how to subnet a network when given a requirement for a certain number of subnets or a certain number of hosts. For more information, please go to hp.com/go/expert1.